Step 5.2 Distance-based methods. In order to be able to apply distance-based methods, what we need is a distance measure, and we need to be able to calculate a distance matrix. That's the first thing we want to now look at. We use an artificial data set for this, that data set Annabil, which is available in package MSA. So you need to have package MSA installed in order to be able to load the data set into R. And if we look at the dataset, we see it contains 7 respondents on 3 different variables. And those respondents indicated the percentage of their free time to spend on any of these 3 activities. So we see Anna and Bill only go to the beach, so they spend 100% of their free time on the beach, whereas Michael doesn't go to the beach at all. And what we want to do now is to calculate the distance between any two of these respondents. So we want to calculate the distance between Anna and Bill, Anna and Frank, and so on and so forth. And this will then result in a distance matrix of size 7 by 7. So the distance between any respondent and another respondent, and also the respondent with themselves. And this can be done using the function dist in R, where you put in the data set, and by default the Euclidean distance is calculated. And we can print this to see now what does our distance matrix look like. And the first thing is we see that here contains numbers, and there are no numbers here, and also that we have only a 6 by 6 but not a 7 by 7 matrix. And this is because what we know about the distance matrix is that the diagonal only contains zeros and that it is symmetric. And knowing this means that you don't need to store the numbers in the diagonal, and you don't need to store the numbers in the upper triangle. And storing the lower triangle of that 7 by 7 matrix is sufficient information to reconstruct the full distance matrix, and you don't need to show any more numbers because they don't contain more information. And that's the way a distance matrix is also stored in R. So function dist doesn't return a normal matrix, it returns a specific object of class dist, where the information is contained that this is a distance matrix, and the numbers contained in the lower triangle are stored. If we want to change the distance measure, we can do this with function dist, and we can specify, for example, that we want to use the method Manhattan distance, and then we get a different distance matrix, which is now calculated using the Manhattan distance. If we want to obtain a normal matrix, we can do this in R using S matrix. So this will transform the dist object into a matrix object, which means it will return a 7 by 7 matrix, which now contains the zeros and also contains values in the upper triangle. The disadvantage of function dist is that it only applies the same distance measure to all of the variables, but in some applications it might be necessary to use different distance measures and to mix them, because, for example, you have a data set where the variables have been measured on different scales. So you want to mix a nominal variable and metric variables together, and such a generalization of the calculation of a distance matrix in this case is available in package cluster. The cluster is a recommended package, so it should normally be installed along with the base distribution of R, so you should have it available on your computer. And the function for calculating the dissimilarity matrix in this case is called Daisy, because Annabil only contains metric variables, and the default in this case is also to use the Euclidean distance. Daisy returns the exact same distance or dissimilarity matrix as we obtained with the function dist.